Okay, so here we have a question on there's two solid prisms, A and B, and you can see they're portions of a circle, portions of a cylinder really, because they obviously have this volume here. Okay, so cross section of prism A is a sector with angle 45 degrees, just telling you what's here, circle radius 10, depth 10, and a mass of 40 pi grams. It's everything's. This is actually a non-calculator from a non-calculator paper. They want everything you can use in terms of pi, so you don't have to actually work that out. So the best way to do this is to really structure it out. There's quite a lot to do because you need to find, you've got the triangle, the density, mass, volume, density, mass, volume triangle, and so obviously we need to find, first of all, find the volume of these shapes, excuse me, and you're given the mass, so it'd be mass divided by the volume to find the density. Okay, so let's start then. So the first thing we need to do is find out the volume for prism A. So I would start with A, and then the pi times r squared, that's the area of the circle, times height, sorry, after the 10 I should have just got h, and then times that by the angle, so that will be 45 out of 360. It's like a portion of the cylinder. I'll put all the numbers in now, I've kind of missed that bit really. 10 squared times 10 times 45 over 360. Okay, and then just rearrange it really. So the 10 squared is going to be 100 times 10 is 1000, so it's 1000 pi, and then you're timesing that by 45 over 360. Now again, it's a non-calculator paper, and you'll notice this 45 goes exactly into 360. 45, obviously two 45s are 90, and then 90 goes into 360 at 4 times, so that's going to be 8 times it altogether. So it's really going to be 1000 pi, and then rather than times it by 1/8, I couldn't just write it as divided by 8. I'm going to leave that there for now. So that is the volume of that one, and then to find the density you would do the mass divided by the volume, so it's going to be 40 pi divided by 1000 pi over 8. Okay, it might look confusing, but it shouldn't be too bad, because you've got, if you remember the rule, the division rule, you can times it and switch the 2 over. So okay, so that works out 40 times 8 over 1000 pi. Now if we just times the top, so 40 times 8 would be 320, sorry, 3200. Oh, sorry, it is 320. I'm going a bit mad. So 40 times 8, 320 divided by 1000, and that should be 320 pi, and that should be 1000 pi. But if you think about the division, the pi cancels down. And 320 divided by 1000, you can maybe cancel this down, 32 over 100, and maybe write that as a decimal. So that is going to be your 3 point. Okay, density. And as a unit, it would be grams per centimetre cubed. Okay, so that's the first one done. I haven't got so much space here for the second one. let's just draw a line here. So the second one is exactly the same. I'm just going to skip a little bit of the working because it's exactly the same. So it'd be pi r squared, so 10 squared times 5 times, and as a proportion, 60 over 360, which is, if you notice, 60 goes into 360 as 1/6. So pi 100 times 5 is 500 times 1/6. So you can just keep it as 500 pi divided by 6. Okay, 1/6 for 500, and then obviously times pi. We just leave it in pi. So that is the volume. And now to find the density. So it's going to be the density of the second one. It's the mass of the second one is 50. So again, we do 50 pi divide 500 pi over 6. And again, we twist it round, so you end up doing 50 pi times 6. So that's going to be 300 pi divided by 500 pi. They cancel down, so that's 3 over 5. And that's going to be 0.6. Okay, hopefully you followed that. So 3 over 5. We know that 1/5 is 0.2, so then I'll just times that by 3, get 0.6. Okay, so we've got the density, grams per centimetres cubed. And now we actually want, so there's a lot of workings on this one, we actually want to express the difference in the densities of the two prisms as a percentage of the density of prism A. Okay, so the difference of the densities, first of all, 0.6 minus 0.32, okay, which is equals to 0.28, and it's as a percentage of the density of prism A. Now, prism A density was 0.32, so to find as a percentage of, we have the difference, 0.28, divided by 0.32, because that's the prism A's density, and then we'd times that by 100. This doesn't look very nice, but 28 over 32, you might notice the number 4 goes into both of those. So you could, I'm just trying to think of the best way to do this actually, so I'm just trying to think, so you could times it up, 28 over 32 over 32, I'm just going to write up here because there's a little bit of space here. So 4's going to all of those, 4's going to 28, 8 times 8. Sorry, I'm going insane. 7 times it's 8, so 7 eighths. So as a percentage, so if I times that by 100, like that as a percentage of, what's the best way to do this really? I'm trying to think without a calculator. So times this by 100. $700 divided 8. Okay, so 70's into 8. Obviously go 8 times and then carry 64, so let's carry the 6. 8's go 7 times, and then we'll be carrying 4, and then that's 5. So it's quite a long-winded question really without a calculator. So 87.5. There may have been a quicker way to find that. I make that 87.5 as a percentage. I've written quite big on here. You could probably have structured that out a bit better in real life, because I think my writing's quite big on this paper. But the important thing is actually that you do structure it out. You kind of make it so this is obviously, because if you make a mistake, they can kind of see where you've made a mistake. So this is, I've kind of drawn a line to separate my A and B. I kind of went down here a little bit for this part, which is fine as long as it's kind of obvious, and then I kind of went up here. So I did use a lot of the paper, but as I said, in real life you'd write a lot smaller than this anyway, so you should be able to structure it a little bit better. Okay, so that's that question done. It gets 5 marks. It's quite a high up question in the paper. Question number 19, non-calc paper. But yeah, there's a lot going on there, so I hope you followed that through. Thank you.